Variable selection in regression analysis is a critical process that involves choosing the best subset of independent variables for creating an optimal statistical model. So far, we have included all given independent variables in our demonstration of regression models. This approach is called anti-regression. However, in practice, we should be selective about including independent variables in our model. Therefore, variable selection procedures are crucial for identifying the most significant independent variable of the dependent variable and improving the accuracy of the regression model. Here, we introduce several typical variable selection procedures for multiple regression: stepwise regression, forward selection regression, and backward elimination regression. These procedures typically use statistical threshold values, such as the f-value, to add or remove an independent variable. Because these procedures do not exhaust all possible models, and preferences vary among researchers, these procedures do not guarantee the best model. However, the choices of a variable selection procedure should be based on the specific research question and the characteristics of the data being analyzed. Forward selection is a variable selection technique used in multiple regression analysis. It involves adding variables to the model one at a time based on their contribution to the model's predictive power. The forward selection approach begins by selecting the independent variable that has the highest correlation with the dependent variable. Then, additional variables are added to the model one at a time, based on the improvement they bring to the model's fit. This process continues until no further significant improvement is made to the model, or until all relevant variables have been included. The forward selection method is often used in exploratory analysis when the researchers have no prior knowledge of the independent variables that influence the dependent variable. It can also be employed in situations where the researcher has limited resources or time to analyze all potential independent variables. One of the main advantages of forward selection is that it can yield a parsimonious model, as it only includes the most significant independent variables in the final model. However, it also has some limitations, such as the possibility of omitting important independent variables that were not included in the initial set of variables. We will now use the heating cost case to demonstrate the forward selection regression procedure. The stepwise procedure first selects the independent variable temperature. Temperature explains 65.85% of the variation in heating cost. The next independent variable selected is garage. Now, the coefficient of determination is 80.46%. Next, the procedure selects insulation and stops. At this point, 86.98% of the variation is explained. When comparing the adjusted R-squared values of these three models, we find that the goodness of fit improves as we add more independent variables to the model. When checking the significance level, that is, the p-value for each individual coefficient t-test, all three independent variables have a significant impact on the dependent variable. Because the fourth independent variable, age of furnace, does not contribute significantly to the overall goodness of fit of the regression model, the procedure stops after including the three independent variables. Thus, the final multiple regression model is cost equals 393.7 minus 3.96 times temperature plus 77.0 times garage minus 11.3 times insulation. Backward elimination is a variable selection technique used in multiple regression analysis. It involves removing variables from the model one at a time, based on their contribution to the model's predictive power. The backward elimination approach starts with the full model, which includes all independent variables, and then removes the variable with the highest p-value, or lowest t statistic, or f statistic, one at a time, until all remaining variables are statistically significant. Once a variable has been removed from the model, it cannot re-enter at a subsequent step. Running backward elimination on the heating cost case, we obtain the same multiple regression result. The backward elimination method is often used when the researcher has a strong theoretical basis for which independent variables should be included in the model and wants to eliminate any redundant or non-significant independent variable. The advantages and disadvantages of backward elimination are similar to those of forward selection. That is, backward elimination can lead to a parsimonious model, as it only includes the most important independent variables in the final model. However, some important variables might be missing in the final model. Stepwise regression is a variable selection method that involves adding or removing variables from a regression model one at a time, based on their statistical significance or contribution to the model's predictive power. This procedure combines forward selection and backward elimination, where variables are added or removed based on their individual contribution to the model's predictive power. Starting with an intercept-only model, variables are added or removed one at a time based on a predetermined significance level. For example, p less than 0.05. At each step, the independent variable not in the equation, which has the smallest probability of f, is entered if that probability is sufficiently small. Conversely, variables already in the regression equation are removed if their probability of f becomes sufficiently large. This process is repeated until no more significant variables can be added or removed. Stepwise regression has both advantages and disadvantages. The advantages include: first, stepwise selection is a data-driven and automated approach, making it useful for identifying the most important independent variables of the dependent variable. Second, the procedure allows for both forward and backward selection, which can be beneficial for exploratory data analysis and hypothesis testing. Third, it can lead to a parsimonious model that only includes the most important independent variables, improving model interpretability. On the other hand, the disadvantages include: first, the significance level for very inclusion or exclusion, typically predetermined, may not be appropriate for all datasets, leading to potential errors in model selection. Thus, stepwise selection could result in a suboptimal model in which important predictors are excluded. Second, stepwise selection can be sensitive to the order in which variables are added or removed, causing instability in the final model. Third, the method is often criticized for being too simplistic and not incorporating enough domain knowledge or theory. In this stepwise regression example, we use a p-value of 0.05 to add a variable and a p-value of 0.1 to remove a variable. As illustrated in the heating cost case, the application of stepwise regression results in the same inclusion of variables as in the forward selection procedure. So far, we have demonstrated 3 different procedures to add or remove independent variables into the regression model. While these procedures can be useful tools in certain situations, it is crucial to consider their limitations and potential pitfalls. They should be used in conjunction with other variable selection methods, model building techniques, and domain expertise.